All right, we are still in section 11.3, simplifying rational expressions. I am on page 692. 692, just FYI, was the number, what we call the hull number, Hull, the hull number of the submarine, the fast attack nuclear submarine that I served on when I was a naval officer. SSN 692, the USS Omaha. Anyhow, I'm still simplifying rational expressions. This one's a little more complicated because I've got a polynomial in the numerator and a polynomial in the denominator, and they can both be factored, and after I factor them, then we can reduce them. We can simplify this. So notice that these have 2 in common. This is 2, and this is 2 times 9. So that's 2, and this is 2 times 9. So that means I can factor out a 2 to the left, and then use parentheses, r plus 9. And if you're never sure whether or not that's correct, I know there's a little glare there. 2 times r is 2r. 2 times 9 is 18. There's nothing much I can do about that glare. All right. Let me divide by this. This is also factorable. This can factor into r plus 9, because this is positive, so it's plus 9 and minus 1, right? R plus 9 and R minus 1. R plus 9 and R minus 1. Again, it doesn't matter what order you put that in. And just double check that that's true. R times R is R squared. 9 times negative 1 is negative 9. Plus 9R minus R is plus 8R. So that does work. Okay, now, before we find the excluded values, which I actually forgot to do on the last one, but it doesn't matter, I can simplify this. So simplify first, and then find the excluded values. So I have r plus 9 and r plus 9 in the numerator and the denominator. So those cancel. They're the exact same term. R plus 9 in parentheses. R plus 9 in parentheses, they cancel out. And now I can write whatever's left over, which is 2 divided by r minus 1, and there's nothing else I can do with that. The excluded value, let's find that. To find the excluded value, all right, excluded value, just set the denominator equal to 0. And so in this case, add 1 to the other side and solve for r, and we get r equal to 1. So there's only one excluded value when it's r equal to 1. Let's do another one. This is a little more challenging, and you'll see why. This is some good algebra, though, folks. It uses a lot of the stuff we've been doing all semester. So let's look at 36 minus t squared. I'm still on page 692, and then 5t minus 30. All right. So if there's a greatest common factor, factor it out. Remember, that's how we always start factoring, is to factor out the greatest common factor. That's true down here. There is no greatest common factor up here, but there is one right here. But this is factorable. There's no greatest common factor, but there is. It's the difference between two perfect squares. A squared minus b squared. The a is 6, and the b is t. 6 squared is 36. T squared is t squared is t squared. So this is factorable to 6 minus t, 6 plus chi la la lula, I chi wa wa, 6 minus t, 6 plus t. And in the denominator, we can factor out a 5 right here, because this is 5, and that's 5 times 6. And so I get 5, I take that out to the side, and that's going to be t minus 6. 5 times, if I redistribute this, the 5 times t, there's that, and 5 times -6 is -30. That works. Here's the tricky part. You look and say, well, wait a second, buddy, these aren't the same, because that's t minus 6, and that's 6 minus t. Tough toodles, poodles. Well, there is something we can do. On either the numerator or denominator, I'm going to go in the numerator. I can factor out a negative sign. This is tricky. I can factor out a negative sign from just this term and put it on the outside. And so if I take a negative out of this whole thing, -1, let me just do it, and then I'll show you what I need. So I'm going to put a negative on the outside of this term, and so I can put t minus 6, 6 plus t all over 5 t minus 6. You say, you can't do that. Well, I just did. But I can. Just take a look at this. If I were to distribute, and we only distribute a number in here in one of the parentheses, or it applies to the whole thing, but when you're distributing, redistributing, you go into just one of these things, because then that whole thing is multiplied by that. So if I distribute that negative, this is -1. If I distribute this back in, I get negative t, which is that. Again, I get negative t if I distributed that. And then negative times negative is positive 6, which is that. It works. This is, they say on page 692, they talk about recognizing opposites. Recognizing that, okay, well, that's opposite that. But if I factor out a negative sign, then it becomes the exact same as that. Okay, I just have this extra negative here. So now I have t minus 6 in the numerator and t minus 6 in the denominator. So let's solve this thing. I'm going to get, that's interesting. Okay, so that's going to be negative, a little more room down here, negative 6 plus t over, that negative sign applies to the whole thing. We put it like down here. That applies to everything. Negative 6 plus t over 5. You can even put parentheses, or I forgot my equal sign. It applies to everything. And you can just leave it like that. You don't really need the parentheses. This is not negative 6 plus t. It's negative the whole term, all right? Well, what's the excluded value? If you're looking at just this, there is no excluded value. But if you go up here, if you were to stop up there, you'd say your excluded value is 6, and that would be valid. But the truth is, you could put you can't put 6 in right here because you'd end up dividing by 0. But if you'd simplified it, then you could put 6 in here because that's fine. All right. Yeah, the excluded value is technically 6 if you were to leave it up here. But I don't like the way they state that in the book, because if you simplify it, you no longer have an excluded value. So I think that I don't like the way they did that. And lastly, rational functions, finding the zeros for something. And do I have time? Oh yeah, I do. I'll just do this quickly. This is the last thing on page 693. On page 693, rational functions. We have done this, finding the zeros for something. The deal here is, what's different is that there's going to be a polynomial in the numerator and the denominator. So we have the function of x, all right, f of x, equals x squared. Can we see that? Yeah, x squared plus 3x minus 18 all over x minus 3. And I want to find the zeros. I want to find the roots of of this function. All right, so we need to solve it. Well, what are the values of x that make it equal to 0? First thing we're going to do is factor the numerator. This is x minus 3, x plus 6, I think, isn't it? X minus 3, x plus 6. Let me just double check. Yeah, it is. X times x is x squared. Negative 3 times 6 is negative 18. And FOIL it, so that's 6x minus 3x is positive 3x. That works. And this is divided by the denominator, which is x minus 3. And so you don't need to put parentheses around it, but I'm going to just to show that that's a term, and that's a term. And they're the exact same, and so you can cancel them out. They have to be exactly the same, and it's good to put parentheses around them so to recognize that they're together as a unit. You can never just like cross out an x and leave the other stuff. It has to be like the stuff in the parentheses have to be identical. The stuff in the parentheses have to be identical in order to be able to do something like that. So we end up with the fact that f of x simplifies to x plus 6. And we're going to find the zeros, just put the function equal to 0. This is, again, these are the x-intercepts on a graph. And so if x plus 6 equals 0, then x equals negative 6 is the 0 of that function. All right. And that's everything in section 11.3. Gosh, that was fun.